Okay, good morning everyone. So, till where we have covered? Lathe machine diagram was over. Major parts over. Now we will discuss about the operations, right? So under lathe, first we have seen definition, right? Second, construction. Okay, working principle also over. And major parts of lathe machine. Yeah, that is parts of this. Be silent. Working principle. Then today we will see different operations. Operations, and the fifth one is work holding device or work holding devices. So we have covered definition, construction over, working principle over, operations. So what are the different operations which are performed? Operations on lathe. So I think all of you have worked on lathe, right? So those who have done, can you name some operations which are done on the lathe machine? Who has done? No, operations, different operations. There were names, turning something. Who knows? Turning, fashing. Have you done? Who all have done work from lathe? Only you. So it's which group? So only 3. Lathe. Who has worked on lathe? Lathe, shaper, milling completed now? Yes. Okay. So do you not? You have not heard about facing, turning, chamfering? So these are the operations which are performed on lathe. Clear? So see, as I have discussed already, that let's suppose there is a cylindrical object, because on lathe which type of job we prepare? Cylindrical jobs. So on this cylindrical job, what are the operations which can be done? So either we can reduce its diameter or we can reduce its length. Take or not? Either we can reduce its diameter or length. Only 2 operations are there. Okay. Can we increase the diameter on lathe? No, because it is a machining operation where we remove the material. So when you are removing the material, you are not going to, you will not be increasing it, right? Anyway. So either we will reduce the diameter or length. So when we reduce the diameter of the job, means what we are going to do? We are going to remove the material from this surface, cylindrical surface. So that operation is known as turning operation. And when we reduce the length of the job, means what we will do? We will remove material from this side, this plane surface. So the length can be reduced. Clear? So that operation is known as fashing operation. So there are 2 operations you must remember, turning and fashing. Turning is for reducing the diameter, fashing is for where is your attention? Okay, so we have one, let's suppose this is the cylindrical object. Okay, so if we remove the material from here, let's suppose its diameter is B1 and length is given L1, and after machining we get an object having the diameter D2 and length L2. when you are going from D1 to D2, that means you are basically doing turning operation, and when you are going from L1 to L2, this is fetching operation. Okay, so basically these two are most prominent operations which are done on the lathe machine. Apart from this, there are other operations also, like turning, fetching, then there is threading. This one is the first one, second one, and third one. Threading. What do you mean by threading? Have you heard the name thread? See, you have seen nut and bolts. So on the bolt, you will see this kind of a spiral impression. That is known as thread. So that is also made on the lathe machine. Okay, so उसको क्या बोलेंगे? Threading. Then knurling. 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 Knurling operation is example like you have seen on the bike handle. So it will not be completely smooth. Rather, on that handle, let's suppose this is the handle. So it will have kind of diamond shapes in this way. It is done to have a better grip. So this kind of impression is done. You will be finding everywhere wherever you holding is required. There, that surface is not completely smooth. Rather, this kind of shapes are made. Diamond shapes. इसको क्या बोलते हैं? This is knurling operation. So that is also done on the lathe machine. And another one is on the lathe you can do drilling operation also you can do. How? So we have lathe machine, this one. This is the lathe machine. We have chuck here. In this chuck we put the work. Okay, and this side we put the drill bit on the tail stroke. This one is the tail stroke. This is the tail stroke. So now this drill bit can be moved. Actually, this can be moved on this bed. This is the bed. So it can drill easily. So drilling also can be performed, but for a limited type of drilling only you can do. Not that everywhere. Like let's suppose you want to drill on this part. It cannot be done. For that you have to go for drilling machine. But some drilling can be done. Let's suppose you want to drill here. Okay. So that can be done easily. And then chamfering. Yes. Chamfering. What is chamfering? You don't know? You have not done on lathe machine? Chamfering, who can say? Yes. Yes. The edge. See, when you prepare the job on the lathe machine, let's suppose this job you have prepared. This one. So what is done? This edge, which is sharp edge, that is beveled. इसको क्या बोलते हैं? Bevel. Bevel. B-E-V-E-L. So beveling, actually, they are made inclined at 45 degree. आपने देखा होगा so many objects are there where the edge will be little bit inclined. So that is not completely sharp. Okay. So see here. So this operation is known as chamfering operation. So we will see one by one. Okay. Already I have given the introduction, but more detail we will see turning, fetching, and chamfering. 3 operations, because in workshop you are going to perform, or you have performed only these 3. Drilling you have not done, knurling also, and threading you have not done. That is not in your syllabus. So we will only see turning, fetching, and chamfering. So let's start turning. Okay, do this diagram, draw this one, because it will help you to reference what I am talking about. This is, you can draw this one also, and you can write knurling, or you can draw this one in front of there. This one you can draw in front of this one, right? This is drilling, so this one is drill bit. Here D1 is greater than D2 and L1 is greater than L2. You can give one example of threading also. So let's suppose this is the bolt I am talking about. So this is bolt, okay, and this is thread. Okay, so let's see turning. So we are working on operations. Turning. So in turning operation, what we are going to do? We are removing the material from the which surface? Cylindrical surface. Okay. So cutting tool will be like this. When you are seeing from the top view, this is the top view. Always we will draw is top view. The top view में क्या है? This is the object and cutting tool is like this, traveling. Clear? तो top view ऐसा दिखेगा. So cutting tool will be at watching. ठीक है? Are you able to understand top view? So from here you are seeing like this. So this can be represented on the page or the board like this. So cutting tool is here. Clear? So material will be removed from this cylindrical surface. How it will be removed? So this cutting tool will be little bit inside the job. So this much material can be removed. This much diameter. Clear? From this side also, because it is rotating. So from this side also this much material will be removed. Clear? And this cutting tool movement will be in this direction. and job movement will be like this. Okay. So draw this diagram here. Draw that diagram here. Which shows that cutting tool. This one you can write cutting tool, and this one is the workpiece. Okay. So write the definition. How can we define it? Turning is an operation of reducing the diameter of a cylindrical object. How? By removing material from the cylindrical surface. Simple. So write down. Turning is an operation of reducing diameter of a cylindrical workpiece by removing the material from the cylindrical surface. By removing the material from the cylindrical surface. Okay. Now there are different types of turning operations. Can you name? Do you remember the names of turning? There were 2-3 turning operations which you have done. Okay. Anyway, one is a straight turning. याद आया? Straight turning. Second one, a step turning. Third one, taper turning. You can give little bit gaps in between this two because I will define this side. Okay? So go on writing that. And contour turning. So these 4. What is the meaning of a straight turning? Straight turning, what we do is, we simply, if this is the job, then what will be my final job? Final work after machining, after the straight turning is this one. That means, what we have done, this is the center line. Only we have done is, we have reduced the diameter. Okay. Or you can say just right here. This is D1 and this one is D2. So throughout the length, we have kept the diameter same. Are you getting? This is known as a straight turning. Means throughout the length of the job, the diameter is same. It's not varying, then it will be known as a straight turning. Whenever you are asked that, okay, this job is of 25 mm, you make it a cylinder of 20 mm, then that will be straight turning. So write down about this one. Diagram पहले आप बना लो इसको. So straight turning, how it can be defined as? So just you can write, here like same diameter throughout length. Same या फिर सेम के जगह पे आप स्लैश करके कांस्टेंट लिख सकते हो, है ना, कांस्टेंट डायमीटर थ्रू आउट लेंथ ऑफ द जॉब, कांस्टेंट डायमीटर थ्रू आउट द लेंथ ऑफ द जॉब. So what we are getting through this? So simply you can define that straight turning is to get constant diameter throughout the length. Next one, step turning. So let's suppose the job is here. Okay, and you are asked to produce this job. So this is a step turning where this diameter is D1, this diameter is D2, and here it is D3. The lengths are, this one is L1 and from here to here it is L2. So this is a step turning. Draw the diagram. This one you have already done. So how you achieved this step turning? Okay, this one is okay. You can just constantly you can move this cutting tool, you will be getting it. But how you will get this one? So first of all, what you have to do? Let's suppose this is 25, this is 23. So only diameter, how much you have to remove? 2 mm, right? So आपको ये जो डेप्थ कितना देना पड़ेगा ना? अगर आपने 2 mm दे दिया तो क्या होगा? 2 mm from this side and 2 mm from that side, 4 mm चला जाएगा. We require to reduce the diameter by only 2 mm. So the cutting tool will be inserted only 1 mm. So from both sides 1 mm will go. This side also 1 mm and this side. So ultimately that whole diameter will be reduced by 2 mm. So 23 you have got already. Okay? But this one is 25. Sorry, total is 25. This is 23, and this you think about 21. Let's suppose. Then what you have to do? Again 1 mm, 2 mm reduction means 1 mm depth of cut. इसको क्या बोलते हैं? ये जो जितना भी डिस्टेंस आप इंसर्ट करते हो, that is known as depth of cut. So this length, or you can say the depth by which the tool is inserted inside the job, is known as depth of cut. So the depth of cut you will be providing is half of the diameter reduction. So that's how you will be getting this one. Third one, okay, definition. Constant diameter यहाँ पे था. Here we will write different diameters on different line or you can say length segment of the job. So different diameter on the different length segments. So it can be like this. Even you can draw this kind of jobs can be prepared. See. This kind of jobs, it can be done. Something like this. So any kind of a step turning, it can be done. Different types of profiles. Okay. Next one is taper turning. So taper turning में हम क्या करते हैं? Diameter को gradually reduce करते हैं. ठीक है? So let's suppose the job is here. But we want to get something like this. So this one is taper turning. So diameter is gradually reducing. So this total diameter is D1, this one is D2, and this is D3. So this one is taper turning. Okay, so write down. Gradual variation in diameter across the length segment, you can write. It may be throughout the length, it may be for a small portion of the job. So the diameter is gradually varying. Variation के जगह पे आप ये मत लिखो, variation is not correct. It will be gradual reduction, है ना? Why? Because I'll talk about that. Gradual reduction. Either it will be reduction or increment. So from this to this it is reduction. So from this side to this side it is increment. Okay, last one, contour turning. So the job is here. And we want a shape something like this. Okay. So this is also a turning operation, where what we are getting a kind of any kind of profile you can build on this, on the cylindrical surface. So this one is known as, so you can get desired profile on the job. Complete. Now let us talk about fashioning. This type of jobs you have seen anywhere. Like let's suppose you have seen there, like let's suppose this desk is there or tables are there. So you have seen its legs, wooden tables and all. So they have that kind of profile, right? It is also a cylindrical job only, but it will have that kind of profile. So that is also done by turning operation itself. Wood turning. Okay. Okay, so let us talk about fashioning. So this is the job, and we require in fashioning what we do? Length reduction, right? So if this is the job of length L1, and if we want the same job but the length is reduced, then this is L2. How you have got this one? By cutting tool, this one. This is the cutting tool. Where it will move? In which direction? It will move in this direction. And job is rotating in which direction? Okay. So this is cutting tool. And this is the job or workpiece. So in the examination, you will be asked, describe different operations performed on lathe. Okay. Describe 5 marks question. Describe different operations performed on lathe. तो आपको क्या करना है? डायग्राम के थ्रू आपको एक्सप्लेन करना है. Don't write only literatures. Okay, definition लिख दिया हो गया. No. If you can draw this diagram, that means it is. I can understand that you have understood what is straight turn, what is a step turn. Are you getting? No need of even writing this one. So it's clear from the diagram itself, right? So diagram are most important. You can represent anything, because अब देखो यहाँ पे you have not written even the complete sentence, still it is clear. So no need of writing one big paragraph, because in examination time you will not be getting that much time. So try to represent your answers in very few words. That is better. Otherwise you have written so many things, but you will not be you can say it will be difficult, because I am telling that diagrams are most important. So my way of checking is that only. If you can represent, if you I will see the diagram, then obviously you will be in profit. So diagrams you try to make it. Facing, what is facing? So this is there. L1 was the previous length, and after doing machining that has become L2. Clear? And so cutting tool will be moving in which direction? In this direction. What is this direction? वर्टिकल, ये तो टॉप व्यू है ना, तो इस डायरेक्शन में जाता है, तो हॉरिजॉन्टल तो ये भी हो सकता है. You have to give some reference. So with reference to what?
Perpendicular to the job.
Perpendicular to the
Job
job
axis.
axis. This is the axis of the job, correct? So perpendicular to this, if you can give the movement, then that will be known as facing operation. तो आपको जब भी ये मूवमेंट जो है वो ऐसा कुछ भी नहीं हो, एब्सोल्यूट नथिंग इज एब्सोल्यूट. So you have to give some reference that okay, this is the axis, and if you can move perpendicular to it, you will be getting facing operation. And parallel to the axis of the job, if you are moving the cutting tool, then it is turning operation. That you can include in the definition of turning. One point you can write below that definition. The tool movement is parallel to the job axis. The tool movement is parallel to the job axis. Okay. Now its definition, how we can define facing is an operation of reducing the length of the job by removing the material from plane surface, okay, or from the cross sectional surface. This is the cross sectional surface. So from the cross sectional surface, if we can remove the material by movement of cutting tool perpendicular to the axis of job. So you can break it also. See, definition is not required to be given in big sentence that everything has to be included. You can give point wise also. First line you can write is, it is an operation of reducing the length of the job. Second, how? By removing the material from the cross sectional surface of the job. Third, by the movement of cutting tool is perpendicular to the direction of, or you can say the axis of the job. So write down. Facing is an operation of reducing the length of the job. Which type of job? Cylindrical? No, not required. Any kind of job it will be. It's not always cylindrical. Any kind of job it will be. Getting? But in case of turning operation, always you will be getting a cylindrical job itself. But facing, let's suppose I want to remove this one. We can hold it in the chuck or not? Can we hold this job in the chuck?
Yes.
Where? In which chuck? 3 jaw or 4 jaw? 4 jaw chuck. We can hold it. But when we will do turning, then we will get a cylindrical surface. लेकिन facing में तो plain surface मिलेगा आपको. Whether it is cylindrical or a square or whatever it is. है कि नहीं? Facing में तो plain surface मिलना है. So it's not mandatory that the job is cylindrical. So we have written reducing the length of the job by removing material from the cross sectional surface of the job. By removing material from the cross sectional surface of the job. Okay, full stop. Next point, the cutting tool movement is along the perpendicular direction of the job axis. Along the perpendicular direction of the job axis. ठीक है? So facing is completed. So length reduce करना है, facing कर लेना है, और diameter reduce करना है, turning करना है. And chamfering के लिए आपको एज पे जो है 45 डिग्री बनाना है, वो हम लोग नेक्स्ट क्लास में देखेंगे. ठीक है? So give your attendance. Yes. Any doubt? Roll number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Anyone else?